Use the graph it right to write a possible equation in y equals ab plus x, or ab to the x form, a possible one. I like how they threw this word in here, and it's because the addition of a plus or minus could have quite a bit of a variation. But if we're assuming that the x-axis is our asymptote, we're not going to have a problem doing this. So there's two values that I can see. I know that if I put 0 in for x, right, I get a half. And when I put in, what did I put in the number 3? When I put in the number 3, it goes up by 499.5. So in other words, this point right here is the point x is 3, y is 500. Okay, so those 2 points I can use to come up with an equation in this form. And the strategy I use is I literally write kind of a system of equations, right? So I'm thinking y equals ab to the x power. I'm going to write, let's see, for this first one, y is 0.5. So I'm going to say, I'll write it as a half. 1/2 equals ab to the 0 power. And the other equation I'm going to write is 500, that's my y, equals a b to the third power. So just to be clear on what I did, each one of these has an x value and it has a y. This point has an x and it has a y. And I've plugged in both of those variables into this equation, y equals ab to the x. And when I do that, I get two different expressions that are true. And I've set up a situation where I'm going to be able to solve for the parameters, right? A and B are my parameters. A is my zeroth term and B is my multiplier. And I can tell by looking at this graph that my multiplier has to be greater than 1 because I'm clearly seeing exponential growth. So the first observation I make is that, well, if b to the 0, because anything to the 0 equals 1, well, if that's just the number 1, this ends up telling me that a is 1/2, which is a surprise not, because that's supposed to be the 0th term. And if I look at my graph, yeah, when x is 0, y is a half. So that makes complete sense. The other thing that I could do is, now that I know that a is a half, I could easily plug that value of a into the second equation. This is going to become 500 equals 1/2 times b to the third. If I multiply both sides of this by 2, I get 1,000 equals b to the third. And what I'm going to do, you can either think about the cube root or raising to a power. I'm going to raise both sides of this to the 1/3 power. So 1,000 raised to the 1/3 power is equal to b to the third to the 1/3 power. So b to the third to the 1/3 power is my friend b, right? My multiplier. And I'm just going to consult with my calculator. I'm going to take 1,000 and I'm going to raise that to the 1 divided by 3 power. Oh, of course, right? 10 times 10 times 10. I'm embarrassed I put that in my calculator, right? 10 times 10 is 100 times another 10 is 1,000. So clearly, yeah, the cubed root of 1,000 is 10. So there we go. I've got my multiplier and I've got my 0th term. So my equation would be y is equal to my 0th term, 1/2, my multiplier, 10, and then the x variable that's driving my multiplication, right, raised to the x power. So again, if you look at this, when x is 0, this is just a half. If x is 1, this is going to become a half times 10. If x is 2, it's going to become 1/2 times 100. It's going to become 50. If x is 3, it's going to become 1/2 times 1,000, which is going to be 500. So this is it. This is the equation that could be used to model that graph.